Good evening, and thanks for joining us. Have you ever had a tough time getting your students to become mathematical thinkers? I know I have, and you're probably not alone. Tonight we're going to work to help your students become better at being better math thinkers, maybe better discourse in talking about mathematics. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. And with us tonight, we have two experts in the field, Nancy Johnson and Tammy Jones. Nancy is a T-Cube national instructor and provides professional development to teachers at webinars, conferences, and workshops. She's been a math classroom teacher for grades 7 through 12 students in Massachusetts for over 32 years. And she believes that technology is a powerful tool that can be utilized to deepen understanding. Her passion has always been to support all learners on their journey to becoming mathematical thinkers. So Nancy, it's great to have you with us tonight.
Thank you, Mike. I'm excited to be here.
And Tammy is currently a consultant working with districts, schools, teachers, and students from kindergarten through pre-service college. She has 40 years of experience in the classroom, with the last 25 years being in secondary mathematics and science. Tammy's been using the Texas Instruments technology since 1974. So Tammy, it sounds like you have a little bit of experience with TI technology. It's great to have you with us as well.
It's good to be here with you, Michael.
And Nancy, will you talk through sort of what we're going to do tonight?
Well, our agenda was, we started with our introductions, and we're going to look at building those mathematical thinkers by developing a classroom culture, structuring lessons so we can bring in all voices, inviting our students to be doers, and using mathematical routines. We're going to get to a TI lesson, and we're going to revise it a bit, make it a little bit more exploratory. And then we are going to serve up our dessert with our assessment probes and consolidation. Questions at the end, and then Mike will get back to everybody with a webinar drawing for a calculator.
Awesome, Nancy. Thanks so much. And Tammy, will you talk through our expected outcomes for tonight?
Yeah, Nancy and I are hoping that when you get done tonight, you will begin to have some ideas of how you can take one of the wonderful TI lessons and design around that this kind of menu and 5-course meal that she introduced in the agenda. So students, first and foremost, see themselves as mathematicians. They actually are capable of doing mathematics. We're going to show you how to select different tasks that will engage your students, kind of encourage some curiosity, some discussion, collaboration, and include those really important written as well as verbal reflections for students. We're also going to show you how the TI technology goes beyond just being button pushing, but actually becomes a tool of investigation and interpretation to allow a lot of students that otherwise would miss some math to catch it. And we're going to look at how you can take and extend the basic content and some of the lessons that TI gives you to meet the needs of all your students, as we all live in diverse classrooms these days.
Well, Tammy, it sounds like we have a couple things we're going to try and get to tonight for sure. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Nancy or Tammy using that Q&A window on the right side of your screen. We'll also use that chat window. It will be important tonight as we send general messages. I know that Nancy and Tammy are going to be asking you questions, and we'd love to hear your responses. You guys are always really great about that. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So we do have a lot to get to, so let's get started. Tammy, you have control. Feel free to share your screen.
I have. I'm going to pop out my chat. And Myra, yes, we're hoping that none of our desserts are going to put out. That is, I'm so glad somebody caught our little analogy there. So, so welcome. You see our emails there. I think you'll have the PDF, so you'll have our emails if you do want to follow up with us about any questions that you have. And also, please encourage using the chat. We're both going to kind of be trying to monitor it tonight. So, Nancy.
So one of the things that we notice when students enter our classroom is many have a preconceived idea of what their math ability is. And what we're going to be trying to do tonight is working with a classroom culture that supports that learning and makes it a safe place for mutual respect and all voices being heard, and also celebrating any small gains that any students may be having in your classroom.
So we're going to start with one of the really nice lessons that TI provides free on their website, but we're going to show you how to actually take one of these activities, create an entire lesson around it, where, as we said earlier, students are going to be discussing math, they're going to be writing about math, they're going to be persevering as they work with the task, and they're going to be thinking both individually and collaboratively. So much like the 5-course dinner that in a fine restaurant that Nancy set up in our agenda, the TI lesson becomes the main course. So we're going to give you some structures to kind of work as the appetizers and the desserts to do this. So we do want, ultimately tonight to be able to show you how you can transform our math classrooms at any level into an exciting and engaging place where we provide opportunities for our students to think more critically and to dig deeper into mathematics.
So Tracy Zager, who probably you're all familiar with, who wrote the book Becoming the Mathematics Teacher You Wished You Had, came up with these action words for our math classroom. And if you just take a quick look at some of those words, those are the kinds of things that are going to build this curiosity and this math culture and mathematical thinkers in our classroom. So tonight we're going to be looking at a lesson that we have taken, and we are going to try to enhance that lesson with our appetizers of getting our students curious, and then getting into our main lesson where we're going to be investigating and exploring and connecting, and then finishing up with our consolidation.
So as we begin, we'll take a look at this slide. Is there anything that you think you might be curious about? What kinds of questions do you think your students or yourself might have about this slide? What kind of thoughts come to mind? So if you want to share some of those in the chat, that would be great. Just looking at these. And we try to provide some for the science folks of you that are out there, some for those that are more geometrically inclined, and then of course for some of you that are more algebra lovers. So just think about that. Think about a question you might have. Slide those in the chat to kind of get us started. So we've already got some coming through. Transformation, scaling, yes. So keep those coming as we keep moving on through, so we can kind of think about and set up some more pieces we're doing.
So as part of our appetizer tonight, we're going to be looking at a few mathematical instructional routines. And the instructional routines are routines that we all can feel comfortable with. And what it does is it provides structure for both the student and the teacher, and gives our students a focus on being engaged and communicating. So that's where we're heading.
We have some good questions coming through. We have somebody that's already noted, ooh, that might sound like which one doesn't belong, so hold that thought, Jay. And then we have things from transformations to symmetry to congruent triangles, sizing. So yeah, one of these things is not like the other, so very good. So we want to get you started with a structure that many of you may be familiar with, Think, Write, Share. I was introduced to an extension of this many decades ago, Think, Write, Pair, Share, because if in the classroom, much as here, we do a debrief by the time it gets around the room, then I say, oh gosh, I liked what Nancy said originally, and Nancy's thought becomes mine, and I've lost my thought. So we're going to use a couple of strategies here. We're going to do the Think, Write, Pair, Share, but we're going to do a timed writing. And we're going to do an assessment probe kind of made for this digital internet environment. So we're going to do a waterfall. And if you've never done a waterfall, what that means is we're going to ask you this question that you see. You've had time to think about it. We're going to ask you to type into chat your response, but do not hit enter. Wait until we tell you to hit send. So if you'll take a minute and type in. And obviously there are some drawbacks to this. If we were in the classroom, we would be walking around. We would be peeking over your shoulder. We would be thinking about which of the questions and answers and how we want to scaffold the responses. So, we don't get the one response initially that shuts everybody down. And again, if you're doing anything online, this is a wonderful way to get an assessment probe in because everybody really is sending it in at the same time. So we're going to give you about 37 seconds, something really weird, additional seconds. So you haven't started, type of one or two things in, some differences between linear and nonlinear. Don't hit send yet. Don't hit send yet. Hang on just a second. Okay, now everybody can hit send. And here they all come. So again, this is a great way to capture an assessment probe, a formative assessment probe on digital. However, in our classrooms, Nancy and I always like to walk around and peek over your shoulder, right, Nancy? See how we want to answer. We can't do that here. But gosh, look at all the wonderful things that you all said. And the cool thing about this is, do you see all the different levels that your students could be entering the conversation? So again, as Nancy pointed out at the very beginning, we want students to see themselves as capable doers of math. Here we are. All of these answers have a place in the discussion, right? About how they are. Oh, we even get some cool math words in there. We got a domain and range. Nancy, do you see anything else that's really?
Well, I see maximums versus minimums. I see growth rates.
Wow. Oh,
See
derivatives.
a calculus teacher with derivatives.
Wow. And so yes, as a disclaimer, we are using a lesson tonight that probably is more of an Algebra 2 type lesson, but you can take it down as well to Algebra 1 in middle school if you wanted to, or you can take it up to derivatives and calculus if you want to. So cool. You all did the waterfall really well. So Nancy, let's do one of those.
So now that you have practiced a waterfall, we're going to look at a notice and wonder routine. And I just thought I'd point out that our little creatures down here, we have Notice the Snail and Wonder the Owl that comes from NCTM. There's a lot of resources on NCTM about notice and wonder. So I just wanted to point that out. This routine is really a big picture routine. You're looking for ideas that you may be noticing and anything that you may be wondering about. In the classroom, when we work on something like this, we always begin with quiet think time for our students, usually about a minute, depending upon what that notice and wonder involves, and give them time to jot down their ideas. And what I usually do is I walk around, as Tammy was saying, and I'm looking to see a hand signal from my students to let me know that, yes, they've found a couple of notice and wonders, or they found 3. And they might have that with that just simple little hand signal, eye check, or whatever it takes. But I'm always looking to see what they've noticed and what they've wondered so that we could scaffold if we were in the classroom. Tonight, we're going to do another waterfall. So if you could take a moment and put in the chat, but don't hit enter yet, what you have noticed. All right, so I guess we'll go for it.
Wow. Okay, let me slow down the chat here. Domain and range, the graph is cubed.
And you'll notice by doing it this way, our answers are really diverse. Our responses are very different.
Yes, isn't that wonderful?
And it's coming in from all different levels of what you teach, just like it would come in from all different levels of where our students are.
And see, Diane, I love the fact you said below and above the x-axis. We all have students that's where they would enter the conversation.
Mhm.
And we want to provide those opportunities for everybody to have a voice in our classroom.
And the graph has an S shape.
Very cool. Hey, Michael, are they going to get the chat?
So at the end of the webinar, if they want, they have the option to save the documents from the webinar, and that would include the chat. Yeah.
Okay, cool. Thank you. Thank you. Should have asked that earlier. Okay.
Okay, and then one more time, we're going to do the waterfall again. And can you put in the chat your wonder, and don't hit enter until we tell you in about 20 seconds. All righty, hit enter.
Ooh, what does it do close to the origin? Why does it cross at the origin? Several people have asked about a compression factor. What is it representing? Yeah, like it's a graph. So what, who cares? Wonder why. What is the window? Isn't that really important, Joy? That really is important.
And isn't it interesting that there are no numbers on the axes?
Oh, why? Answer from TI-84. Interesting. Window and scale. Yes, that would be most important. How do we get to the scale? Cool. Very good. Gosh, Nancy, they did well.
Absolutely. All right, so as we look at these, you've seen two math routines right now. Think about how this would affect learning in your classroom. And think about how it will help to bring in all those voices that are out there, not just the one or two that want to raise their hand. So, all right, I think we are beginning our main course. So with our main course, we're now looking at a graphic organizer. And this is a web that was created to basically, it is almost like an assessment prompt in a way, because we're trying to make sure that our students have the vocabulary for the rest of the lesson and that they're making the connection. So here, notice that our action verb is observe. And so we're going to the graphing calculator, and they would be taking a look at y equals square root of x. Tonight's lesson is going to be on radical functions. So this was looking at the parent function and then discussing some of our vocabulary words here: range, intercepts, graph, table of values, symmetry, anything that anybody would come up with an appropriate number of spokes. If they wanted to add more, they could.
So do we want them, if they have a calculator handy, to graph it and just kind of get a sense of how they might fill in
I think
some
that
of these
might be a
parts?
good idea.
And I like the way you use some of their academic vocabulary. So we're kind of prompting them on some of those nice words that we're hoping they're going to use as they write about or discuss about. And I'm not exactly sure, we're to assume our lesson is all digital. I'm not
Yes.
exactly sure what you mean by that. We are digital tonight because we're on the internet and doing a webinar. But no, if we were in the classroom, this lesson would be, the students would actually have the graphic organizer, and they would be able to actually use their calculator as a tool of investigation and put it in, do the answer, capture everything. I don't know if that answers that or not. Hopefully it does. Okay. Do you think they've had some time? Should we move on, Nancy?
Sure.
Okay. So as Nancy said, this is radical functions. This is a lesson from Texas Instruments. You are going to get the link to the lesson. And one of the nice things about the lessons from TI, they do give you a Word format. So you can take the Word document as a place to kind of begin working with it. They do have the screenshots from the Smart View, which is what Nancy embedded with the graph and the pictures here. So that is a starting point. This task is a higher level math topic, but again, it's easily adapted. We're using the TI-84. It also can be adapted for the Nspire.
So at this point, we're going to go into our main course, and we're going to be looking at our new lesson that is based upon TI's radical function lesson.
And you will get this. Nancy created this wonderful little like version and adaptation of it that we kind of played with and checked and tried to make sure everything was good. So the students have like something to do, and then they investigate and actually respond. So let's look at our radical function. So I'm going to play Vanna. So I have put in, I went to graph and I did put in the square root of X. And so do I just graph it now?
Yes, you do.
Okay, there it is. So what do I know about it?
And you've got the prompts. So hopefully, because we've already discussed a little bit about this, we would be able to enter and see. One of the things I would do if I were in the classroom was I would probably have them work this on a mini whiteboard, and each one so that they could take a look and see what each other has and share what they've come up with. And making
this
sure.
might even be a good exit ticket the day before. So they do it at home and bring it in the next day as the starting prompt for the class.
Exactly.
Because you don't have to print and give them everything stapled together. They could get one piece of it at a time if they wanted to.
And this could be put up on a smart board in front of the room, and the kids are just sitting there with their mini whiteboards.
There you go. So now we're going to explore.
And so once we're in the Explore, now we're going to the Transformation app.
So apps, and I'm lazy. I always tell my students, so instead of having to scroll down, I can scroll up, and there's Transform. So again, I went to apps. Notice I'm on the emulator and it stays red what I just clicked. And again, I'm lazy, so your arrows work both up and down. Transform does not have a numerical quantity. If I wanted like easy data, I could press 5. So I'm going to scroll up because I know Transform's at the bottom. And when I hit Transform, if you notice at the top, I now at the breadcrumbs, it tells me that the Transformation Graphing app is active. So there it is. Press any key. I'm going to press graph. So there's my y equals. And now that is transformed. But you want me to kind of modify that, don't you?
Well, we're going to leave that as y1, I believe, right?
And yes, and then we're going to go down to.
Yeah.
So now I've got to put in these variables. And unfortunately, if you go over to the transform menu and you look at some of the options that are here, some people do not realize that in the transform menu, there are functions already built in. So just an FYI, there are functions already built in. So there's your basic linear, quadratic, vertex form. We don't have the radical though. So we're going to have to do the radical ourselves. So let me get back to the end. Let me go, okay. Come back over and notice there are only 2 transform functions now. So you still have the opportunity to put other functions in if you want to. So I have got to go to alpha, which is green. And actually, I guess I want to do my alpha lock and let it be A. So there's my A. I want my radical, which is in blue, so second function for my radical. I want parentheses open. I want my x for my variable, so my x tau theta button minus, oh dear, what did I do?
Tammy, it didn't get your
It did not.
parentheses.
Let me go back down. Hang on. Let me come back here and let me delete. Come on, come out. Now let me go back and delete. There. I'm not sure what I clicked. What did I click? I don't know. Parentheses. There it is. I wonder what I hit.
You just didn't get the
Oh, my alpha log was on, somebody said. I
Right.
probably did leave my alpha log on. See, you all are so good. You all take care of us. So there's my x tau theta. So I need to turn my alpha log off. Maybe I turned it off now. Let me see. My x tau theta. No, it's still on. So this is, I mean, this is what happens in the classroom. We have these things happen. So alpha log off. Maybe it's off now. I think I keep hitting it. I keep turning it on. Okay, let me. This is where on the Inspire we have our nice escape button. Let me clear. There we go. X tau theta. Then we want it to be minus B. So alpha log B. Now we want to close our parentheses. Yep, same thing. I did it again. Delete. Turn alpha log off. Oh, I did the whole thing again. So I did not plan this way. And I'm glad this is happening this way because so many teachers think, oh, I can't do technology in the classroom because what if something happens? Something happens, so what it happens? Close parentheses. And now I want plus C. So out. Did you notice what just happened there? That's important. And this is really important for students to know they're out from under. And now I'm going to do my alpha log C. So there are your variables. So now what am I going to do?
I think we need to go to our graph, don't we?
And there it is. So notice there's my parent function. There's the one that we struggled and I got in finally. We have A, B, and C, and they have rather funky values at the moment. But I can go to setup. And this is one of the things, I am viewing this with the handheld to the left and the screen to the right. So setup would actually be over my graph key. So if I hit my graph key, that will give me the setup. And I want to just start that at 1. And I want the other ones to start with to be 0. If you look on the lesson A1, B0, C0, and I do want to step by 1. So now I can go back and graph. And there it is.
But they look the same. What happened?
What happened? So somebody tell us what happened. Why do they look the same? Did I lose my blue one? Why do I only have a red one? So no vertical or horizontal shifts.
Yeah.
100 is the square root of x. How about that?
So we actually have the parent function right now.
So I actually, the blue one is hiding.
It is hiding.
So yeah, and for some students, this is like remarkable. They're like, oh, I've lost my function, but no, it's still there. So do we want to play a minute?
Well, yeah, and if we play with the first part here, we're looking for A between 0 and 1. So we're looking for our fractions, such as a half and a third and a fourth, and let them grow, I guess, until 1. But we need to show how to do that. So Tammy just went to her graph
Setup.
settings and setup.
So how do you want to step? You want to go a tenth? You want to go 0.25? You want to go?
I think I would have done 0.1 just so, but you know, I mean, that's again up to the student, just so they can.
1/10.
And now here, Tammy's going to change that A equals 1, but not affect the B and the C. And she does that with her left-right arrows.
So here's a really important pedagogical question. Why did moving up and down not affect anything, but moving right and left does? Because this is one of the things we try to reinforce with our students, and TI has been doing it since the inception of their graphing calculator. So why am I only able to change A? And even if you're doing like the intersection, you know, up and down jumps your functions, it doesn't move along the function. I still have to do my right and left. So why am I doing my right and left?
And so we have in the chat, C is still 0. B is still 0.
But I'm actually changing what part of my function. So this goes back to like middle school when we first introduced functions. What part of my function am I actually changing? Think about not domain and range, but what we call them in middle school. Input, Jessica got it. So we're changing the input, and the input is along the x-axis, right? Input, domain, x-axis, all of those things. And I just think this is a really important feature that gets overlooked and not talked about enough in the calculator. We are changing the input, and the input is always along the x-axis. So I'm changing it. Now over here, I would be collecting my data, right?
Yep, you're going to be comparing to your parent function, which is staying in the blue.
And if you want to see the tables, you actually can see tables. So if your students need to see the table for the values, they can go to table and see the table values if they need to. And then we have them describe.
And as we're doing that, this is probably a work in individually or in pairs right now, as the students are progressing through this exploration.
So Myra, the Inspire, you could write a document to have the Inspire collect data, not on the 84 as much. You'd have to, like, I guess, write a program that they could run that would do it, but it's not built into the system like it would be on the Inspire. And Kathy, with the 84 plus, if you go back and look at the y equals, I have two inputs now that I can transform. So I can now transform in y1 and y2. And yes, the error is undefined. Okay. I cannot graph two equations. Oh, Kathy, really? Are you,
I
do you
wonder,
have a transform app on?
are you on an 84 CE or an 84 plus?
Yeah. We're on the 84 CE if you notice this. Oh, that's why.
I think that's why.
Yeah, that's why, your operating system. So we're on the CE. So back to the graph, we're collecting data. So things kind of happen here between 0 and 1. Then where do we go? We go greater than 1. Oh, there's that magic where it's hiding the blue. Now
And
it's
at that point, we might want to change your step, but
so now
again,
what do you want me to change my step to?
probably increase it
By
1.
so just go 1.
Yeah.
So now let's come down and let's step. So wow, square root, when I change A, really gets higher quicker. But remember, A is what? A is the coefficient outside of the radical, right?
Mm-hmm.
So a lot of students sometimes will question, but shouldn't that be under the radical? But it's that it's nice for them to realize, here's my A. My A is that coefficient. So the coefficient is operating on the entire. So that's what's happening. And then we look at between 0 and -1. And you want us to go back now to graph.
And probably go back to the point 1 for the step.
And do the point 1. And then you also want me to come here and in Y3, put in the square root of the opposite of the square root of X. Not negative, not the minus, but the opposite of. Okay. Wow, that's cool. A sideways parabola. But we want to go here. So here I am going between 0 and -1 now. Is the OS update. Kathy, if you have an 84 plus, you can update it so much, but you will not get all the features that the CE has because it is a completely different operating system.
But it does have the transform, so at least
It does, yeah, it does have the transform.
Yeah.
And then you have us go with it being less than -1. So do you see how the lesson was transformed? No pun intended. Broke down each of the pieces. And again, Nancy made these very bite-sized. I'm looking at what happens, as somebody asked earlier, what's happening around the origin. So what is happening around the origin? What's happening between 0 and 1? Then what's happening if A is greater than 1? Then what's happening if I am on the negative side of between 0 and 1, between 0 and -1? And then what's happening? And then here we are doing our writing, hopefully using our math words. We're having to now verbally explain what the effect has. Okay. And then Nancy, same thing for B.
Yep, we're going to put A back to 1, correct?
Going to put A back to 1. Let's see, for B, and then we want B to be greater than 0. So what do you want to step by?
1.
Just 1. And so now when we graph it, we're going to go to B, and now we're going to start. Oh, it disconnected from the graph. It's almost in midair now.
And now think about the vocabulary that would be coming up here with your vertex changing and your translation that's occurring. And so your domain is now changing.
And let me go back. I'm going to turn off, in case you don't know, I can turn off equations. So for right now, I'm going to turn off the reflection. So I don't have to really see that one and worry about that one now. Isn't that interesting how it kind of floats down and almost touches the axis, but then it hops back up and it doesn't touch the axis? So, and you will have the opportunity to explore the activity because you're going to get the activity. So you can play with it at your heart's desire. So again, you go through all of these, right? And then we have the effect of the changing B. And then we have the effect of the changing sea. So is there something in particular, Samuel, that you wanted to explore? Does the window move as it would on Inspire? What do you mean? Oh, I know what you mean. No, no. The window here is fixed by the window settings. You can, in a document, drag a window. If you get your, claw and you close it, you can like drag and shift over. The windows here are stable and fixed. They're a function of the window setting. So yeah. So Jay wants a horizontal translation rightward. Okay, Jay, how would I do a horizontal translation rightward? What of these three variables do you think would make it give me a horizontal translation rightward? Say that 3 times fast.
And that is actually in the exploration.
It is.
We just kind of skipped over it for tonight.
Move B. So if I'm moving B, there it is going to the right. It's now off screen. If I want to see more of that, I go to my window. And since that's the X max, I just need to make the X max be something bigger. At this point, I'm not even going to change. I'm just going to squish there. So the graph squished. But now you can see it moving further. No. And George, if you remember, let me just show you, George, while you're thinking, so you'll see. If you remember when I went to the transform all the way to the left and hit enter, and come down to Y1, it gives me, if I go to the left instead of the right, remember I'm lazy, so I tend to like to go the shortest path possible. You have your functions built in for trig. So the trig functions are already built in for you. You don't even have to type them in. And your students don't have to type them in. So they're already there. So those are there.
And it's a good question because it shows you how it has the A, B, C, and D, which is necessary for those functions.
So, okay. So does anybody else want us to move anything else to see? And you say you could do this same activity. Now, lines are boring. So doing this with a linear function is not going to do much for students. Quadratics, could you see how this could easily be adapted for quadratics? For cubics? Gosh, Nancy, for any of the family of functions, right? I mean, this activity is adaptable for any family of functions. It's just linears are kind of boring because you don't do a whole lot with linears.
Except it's nice for the students to see that connection between point slope form and bringing that y minus y1 and bringing that y1 over to the other side and seeing that lines really do follow the same pattern that we're seeing here.
And the point slope form is in there, right? The point slope form is in there.
I think it is.
If I remember correctly. Let me hit enter again, but let me go to the right and
it's all the quadratics right now.
Yeah, maybe not. It's just no, it's just that. So I don't think the point slope form is in there.
Yeah.
But you could put it in there. You could easily put it in there. Absolute values are very nice. Yes. And yes, Jay, Tom has a wonderful, on the TI website, well worth anybody's time to go check it out, the Family of Functions resource. If nothing else, I mean, I've shared it with some of the folks that I work with over on campus, and the Families of Functions, that whole sheet is just amazing. Especially if you're teaching Algebra 2, Pre-Cal, Trig, or even the calculus. It's just a wonderful reference sheet. And then all the videos that go with it are there. Okay. Anything else on this before we leave this and get back to dessert? Is everybody ready for some dessert? Okay. So for our first dessert, Nancy.
Oh, okay. We are looking at, notice we are now at applying what we've learned. So we've moved from the exploration into the application. And so for this first dessert, this is something that you could do at the end of your class after you've done your exploration. And what it is, it's called an infogap, and illustrative math uses this a lot of times. It actually was, I think, developed back in the early 2000s. People, I don't think a lot of us were aware of this as a math routine. But what it does is it's really a partner routine. And in that partner situation, you are going to give a pair of students two different cards. One of the cards is going to be information, data, graph, whatever. The other card is going to be the actual problem, which the student that has the info card doesn't know what the problem is. And the student that has the problem card doesn't know what any of the info is. When I have done this in class, I have my students pretty much use a mini whiteboard with their cards set on the mini whiteboard with their backs to each other. And the reason for that, usually you want to have people talking with each other face to face, but the reason for that is because it really creates the idea that they need to be able to communicate their questions and their responses accurately. So they can't see those facial expressions, and it really, the kids usually love it after they have done it a few times. In the beginning, and if you try it yourself, I've done it and it's hard. But it actually brings out, it forces communication. Again, all students are going to be involved. If you have an odd number of students, in that case, we just try to pair up two on one of the info cards or two on a problem. So it becomes a group of three. The big thing that I like to do is make sure that I've at least have done two different situations with the kids so that they can exchange their roles. But you can see the kinds of questions that we came up with and the information that they're given. So this is a, here they're taking what they just explored, and now they're going to be trying, like, look at the difference in the questions. Give an equation for a transform function, what transformations have occurred, and what is the vertical shift. So 3 different types of problems, and then the info is different on each one of those.
And one of the things, Nancy, that I have done when there were 3 people and then it kind of worked so well, I started doing this occasionally with 3 students, is let that third student be a scribe to capture the dialogue. So it's actually down because the students have learned a lot by studying their questioning and their communication. And over time, it gets better and gets more sophisticated. So that's just an option for something to do with the third person.
The other thing I wanted to mention too is at the end, when the student that has the problem is content with the information that they've gotten, I still keep those students back to back, because what's really interesting, and Tammy, you made me think about that, was that they go ahead and they solve it differently. And it's really interesting for them to look at each other's work and compare and contrast.
Okay. So that's one dessert. Remember, this is like a 5-course meal. So we want to give you some options. Okay. So we have another option for you.
And this could also become an appetizer for the next day when they walk into class. It could also be a 1 problem homework problem if you wanted to. After you finish this lesson, you could send them home with this. So, you have multiple ways that you could use. This is that graphic organizer coming back in, but now it's got the information with the transformations.
Okay. So that's another option. And then remember that very first thing. So we're going to circle all the way around and come back to where we started at the beginning. So I prompted you with some pictures, and somebody, it may have been Jay, said, oh, it looks like that might be which one doesn't belong. Well, here we go. These were all made from the Smart View, because with the Smart View, I can take a screenshot. And when I take the screenshot, I just have to know like where I'm going to save it, because here it is. Oh, let me see. Did I pull up the wrong one? No, here it is. It's over here. It is hidden. Here it is over here. So here's the screenshot, and I can save it. I just have to know where I'm going to save it. So I do want to save this. So I can save it as something. And then I have it later to drop into a document. And I don't want to save that. So here's our which one doesn't belong.
And again, how you use this, whether you use it at as an exit ticket, whether you use it when your students come in the morning or the beginning of the next class, again, it's up to you. And as Tammy was saying, I had never done this before. I had always just numbered them as you see 1, 2, 3, and 4, and had them enter their information. It is interesting to see which one comes to mind first as it doesn't belong. And notice the other part here is it's not just which one doesn't belong. You've got to complete the because and explain.
So take a minute and just think about which one jumped out at you initially as not belonging and why, and send us the number and the why. Just curious. And it does tell you a lot about how students think. Michael says they all belong. Well, that's the point. They all do belong. But are there reasons that your students might see one that does not belong versus another one? Ooh. Oh, let's see. We got some. So 4. Oh, I love this. Okay, 4 because left-right transformations, horizontal shift. 3 because they have concave up and down. So see, even and this is such a low floor, because again, we're really thinking about trying to let everybody, all of our students, know that they're capable of doing math. So
And
again,
I like that one, that here you go with this low floor. Number 3 only shows 2 functions.
Simple
Simple as that. Yet,
as that.
and
And
yet
it's
that
correct.
voice is valued.
Yeah.
It's awesome.
So number 3 is the only one that has both a min and a max. And do you see the way that you all are answering using different language? A rising tide raises all ships. So it's really nice to think about allowing the voice to be heard, whether you do something like Nancy said with a whiteboard, whether you do like a waterfall, whether everybody does a think, write, pair, share, or they share it out, or they all say because, and then they report out. So yeah, so that is another dessert option. Because one of the things that we tend to not do very well, that's very, very important in learning, is that consolidation. At the end of the lesson, building that time in. So you have come back around and talked about, we presented you a way to use a rich TI activity, add an appetizer, expand the main lesson to really let the calculator be a tool of investigation, to make it collaborative for students as well as they could work individually, and then to end with some dessert to wrap it up, to do some assessment probes to check in where they are.
And think about the culture in your classroom by doing by doing any of these activities. Appreciating what every voice has to say and offer towards their learning.
And you are going to get all of this. We're giving you all of it. Okay. So we wanted to end, we began with some quotes. We want to end with a quote. So Pele, which I'm sure probably everybody on here knows who Pele is. I love this quote by Pele: "Success is no accident. It is hard work." Math, even for mathematicians, is work. Sports is work. And that's something that I think sometimes we try to create this wonderful disposition of math, and we forget to let students know math still is work. So we have to acknowledge that it is work. It does require them to persevere. That's one of your standards of practice. We are learning, we are studying, we are sacrificing some time. Most of all, we need to love what we're doing or learning to do. And hopefully you are passionate enough about what you teach that your students know that. One of the greatest compliments I ever got, I had a student one time say, Miss Jones, you're just not like any other math teacher I've ever had. And I'm like, thank you. I'll take it as a compliment. Because I did all this weird stuff, but they learn math. So we leave you with that. And we leave you with, if you have any questions. So any questions before we turn it back over to Michael?
Well, there are a few questions in the chat.
Oh, cool.
So where do you
where do you find
functions reference?
Okay, hang on, and I will show them. So I happen to be, I think, on the TI website.
So education.ti.com.
Yes, education.ti.com. I will send that to the chat. And then if you look at the resources, under resources, so I'm over here under resources, I'm going to come down and over families of functions. So let me send this link through the chat. Videos, functions, you do want to download the quick reference guide, because when you download the quick reference guide, this is just like, is that not worth its weight in gold right there? To math teachers. And then all of these are hyperlinked. So here's the website. So yeah. So
and before you get rid of that, all of those lessons, all of those functions, you can do transformations with pretty easily just by changing the parent function that we started with.
For sure. That one lesson we did fits them all. And so this is 22 pages long. Okay. So this is just a great resource. And again, education.ti.com under resources is the family of functions. So thank you. We enjoyed putting this together. So I'm going to stop sharing, turn it back over to Michael.
Awesome. Thank you so much. As we wrap things up, one thing that I did want to show, again, on our website, education.ti.com, I think Tammy was just there, and I'm going to that same resources tab, but I think some people had some questions about how to update their TI-84. So real quick, I just wanted to go to tutorials, and then you can scroll down to if you have a TI-Nspire, or let's say you have an 84, go under graphing tutorials. And there's a link here for the TI-83 Plus and TI-84 Plus graphing calculator families. You click on that, and on the right-hand side here, you see all of these different tutorials. Scroll down to using TI Connect is one way to update your operating system. And right there, it's a 3-minute video on how to update the operating system of the calculator. So real easy to check that. And like Tammy showed, there's... Go ahead, sorry.
Yeah, and TI Connect is free.
Yep, available as a download on our website.
Yeah.
So we also have mentioned earlier that one lucky winner is going to get a TI graphing calculator tonight, and tonight's lucky winner is Adrian Howard. So Adrian, congratulations. We'll be reaching out to you in a couple days to get some information from you. But congratulations on receiving the TI graphing calculator of your choice tonight. To download a certificate of attendance, go ahead and click the link that I put in the chat window. Also lists this link for the documents. I know some of you are really wanting those documents from Nancy and Tammy. Go ahead and click that link for those documents, and they will all be there. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. And if you happen to miss the links or the links aren't working for any reason, you'll automatically get a follow-up email in a couple days. And that follow-up email will contain links to the recording, the documents, the certificate, everything you could possibly want from tonight. So with that, a huge thanks to Nancy and Tammy for putting everything together for tonight. Thanks so much.
Thanks, Michael.
Thank you, guys.
And thanks so much, everyone, for joining us. We hope to see you back online next week. Have a great night.